Now question is, find the sum to n terms. That means we want Sn of this 333, 333, 3333. Okay, this sequence. So how we can find the sum? First check whether these given terms are in AP or GP or some like HP. So here 33 minus 3 is 30. 333 minus 33 is not 30. So this is not AP. Now check for GP. Is it GP? 33 upon 3 is 11 and 333 upon 33 is not 11. So again this is not GP. You can check for HP also. So how we can find this sum of n terms? Either we want AP or now we want GP. So let us try to write this in terms of some another sequence which is either AP or GP. So for that, now technique is, here as all terms are 3, try to convert these all terms in 9. That means in place of 3 we want 9. Then we can solve easily. Okay, so how we can convert this into 9? First start with this, say suppose this is S, 3 plus 33 plus 333 plus write this. Now write here 3 common. 3 common, so this is 1 plus 3 common 11, this is 1 1 1, this is 1 1 1 1, 2 n terms. Right here 2 n terms. Again here this is same case, this is not AP or GP, but as we want here 9, now here multiply and divide by 9. So 1 plus 11 plus write the same 2 n terms. Now this 9 right here. So multiply each element by 9. So 3 by 9 write same. 9 into 1 9 plus 99 plus 999 plus 9999. 2 n terms. Okay, again this is neither AP nor GP, but we can solve now easily. So first write this as equation 1 here. This is what? S. Just simply write as S. Now how we can solve this? 9 we can write as 9 we can write 10 minus 1. 99 we can write 100 minus 1. This 999 we can write 1000 minus 1. Continue this. 2 n terms. Okay. Now from these brackets separate the terms. Write first term separately and second terms separately. So 3 by 9. 10 minus 1 is 9. So again we will get same. Okay. What we want now? Write first term separates. So 10 plus 100 plus 1000, 2 n terms, minus, as second terms are minus 1, so write minus sign common. We will get this one here, this one plus 1, 2 n terms. Close the bracket. Okay, now don't write here equation 1, let us write this equation 1. Now we have to solve this. Now check, this is the GP and we can find this sum easily. So write here now equation 1. So now write this here as equation 1. Now for this sequence, as 10, 100, 1000 are in GP, these terms are in GP, with first term A is equal to 10 and R is, divide second term by first term, 100 upon 10 is 10. You can check here 1000 upon 100 is 10, or you can check next term. So here common ratio is same, constant. So this is a GP. And we know how to find sum of n terms of GP. So here, now Sn, that is sum of n terms of this GP. Here we write some S, just for difference. So here sum of n terms of GP Sn is a into r raised to n minus 1 upon r minus 1. A is what? 10. R is what? 10. Raised to n. N we don't know. Minus 1 upon r minus 1. So 10 into 10 raised to n minus 1 upon 9. Over. Now the second. 1 plus 1 plus 1 n times. How we can solve? We know that 1 plus 1 is 2. 1 plus 1 plus 1 is 3. 1 plus 1 plus 1 plus 1 is 4. So if it is n times, we will get n. Okay. 1 plus 1, 2 times 2, 3 times 3, 4 times 4. So n times it is n. So here answer is n. So from equation 1, S is 3 upon 9. This sum of n terms of GP is Sn here, and that is 10 into 10 raised to n minus 1 upon 9. Minus this 1 plus 1 plus 1 n times, that is what? N. Simplify this. So this is 3 by 9 cross multiplication. So 10 into 10 raised to n minus 1 minus 9n upon 9. Okay. So now actually 3 by 9 we can write here 1 by 3. Okay. So here this is 3 by 9 which we can write 1 by 3 into this 9, that is 1 by 27. So 10 into 10 raised to n minus 1 minus 9n. Okay. Or you can write 9 into 9, 81, that is 3 upon 81, that is 1 by 27. Now here for second only difference is here 3 is given and here 8 is given. So here we have to use exactly same method, only replace 3 by 8. So here write 8 common, this will become 8, multiply and divide by 9. So here 8 upon 9 we will get 8 upon 9. So write here 8 upon 9, 8 upon 9. So up till this write same. That's why I write here 3 by 9, not 1 by 3. So here we will get 8 by 9. So answer will be 8 by 9 into 9, 81. Okay, 8 upon 81 into this. Okay, this part. So only difference is just replace here 3 by 8 till this. Okay, and then write the answer 1 by 81 into 10 raised to n minus 1 minus 9n. That is answer. Or here suppose 8 is given or 7 is given or some 4 is given, 5 is given. You can use this exactly same method. Okay, so you can take screenshot of this if you want. In this sum, this is now similar to previous sum. We want sum to n terms. Here this is 0.4 plus 0.44 plus 0.444 to n terms. So again you can check these terms are neither in AP nor in GP. Okay, so again like previous sum, we will convert this into some another sequence which we can solve easily. So we want to replace 4 by n first, 4 by 9, then we can solve easily. So again method is same. Right here 4 common, we will get 0.1, 0.11, 0.111 to n terms. Now we want 9. So multiply and divide by 9. 2 n terms. Now this 4 by 9 write same. Here 9 into 0.1 write 0.9, 0.99, 0.999, 2 n terms. Again these terms are neither in AP nor in GP, but we can solve this easily. How we can solve? So 0.9 write as 1 minus 0.1. 0.99, how we can write 1 minus 0.01. Don't write 0.11. 0.99 we can write 1 minus 0.01. Check this. Add this and this. You will get 1. Next. 0.999 we can write 1 minus 0.001. 2 n terms. Now separate first terms and second terms. So 4 by 9. First term is here 1 plus this 1 plus this 1, 2 n terms. Minus we can write common from second term. So all are negative, so write minus sign common. This is 0.1, 0.01, 0.001, 2 n terms. Now this we can solve easily. 1 plus 1 plus 1 n times is n, and these are terms which are in what? GP. Check this. Common ratio is constant. So we know how to find sum of n terms of GP. So let us write here equation 1. Now 1 plus 1 plus 1 n times, you can write 2 n terms. As 1 plus 1 is 2, if we add 3 times, that is 3. If we add 4 times, it is 4. So if we add n times, this is n. And 0.1, 0.01, 0.001 are in GP with first term A is 0.1 and R. Divide second term by first term. Again you will get 0.1, which is less than 1. So sum of n terms we want. So write Sn. So this is A into 1 minus R raised to n upon 1 minus R. Now A is 0.1, R is 0.1 raised to n upon 1 minus 0.1. So 0.1, 1 minus 0.1 raised to n. 1 minus 0.1 is 0.9. 0.1 is 1 by 10, this is 9 by 10, cancel out 10, 10, you will get 1 by 9. 1 minus 0.1 raised to n. So, from equation 1, this is what? This is S. We write this as S. So, from equation 1, S is 4 by 9. This is what? N minus, this second is this Sn, that is 1 by 9, 1 minus 0.1 raised to n. So now solve by cross multiplication. 4 by 9, this is 9n minus of this. So you can write 1 minus 0.1 raised to n upon this 9. So 9 into 9, 81. So 4 by 81, 9n minus 1 minus minus plus 0.1 raised to n. So this is our answer. You can take screenshot of this. Now question is, find the sum to n terms of this sequence. So check whether this is AP or GP. So clearly this is what? GP. Find out common ratio. 0.05 upon 0.5 is 0.1. This upon this is 0.1. You can observe here 0.5 is given, 0.05 is given. So 0 is extra. Then here there are 2 zeros. So this is increasing by 0.1. So R is what? 0.1. So here you can write 0.5, 0.05, 0.005 are in GP with A is equal to 0.5 and R is equal to 0.1. This is less than 1. So question is find the sum of n terms. So Sn is A into 1 minus R raised to n upon 1 minus R. Okay, you can use any one from two formulas, but here R is less than 1, so let us use this. So A is 0.5, R is 0.1 raised to n upon 1 minus R, that is 0.1. So this is 0.5, 1 minus 0.1 raised to n. We cannot subtract this. This is 1 minus, this is 0.1 raised to n. Okay. So 1 minus 0.1 is what? 0.9. So this is 5 by 10, this is 9 by 10, cancel out 10. So answer is 5 upon 9, 1 minus 0.1 raised to n. You can write bracket here also. Or 0.1 write as 1 by 10. So this is our answer. Now here Sn is given and we want nth term, that is Tn. So from Sn, how we can find Tn? So Sn is 2 into 3 raised to n minus 1. Now from Sn, either find out Sn plus 1 or find out Sn minus 1. Let us find Sn minus 1. So as here we write n minus 1 in place of n. So same right here. Replace n by n minus 1, remaining all right same. So 2 into 3 raised to n minus 1 minus 1. How we can find Tn from this? So now see here, what is Sn? Sn is T1 plus T2 up to Tn. Now Tn means nth term. So if we want, suppose previous term of Tn, what is that? That is what? Tn minus 1. Okay. Now what is Sn minus 1? Sn means sum of first n terms and Sn minus 1 is sum of first n minus 1 terms. That is, this is first term, second term, this is Tn minus 1. So extra term is there Tn because this is sum of first n terms and this is sum of first n minus 1 terms. Now subtract this. So Sn minus Sn minus 1, T1 cancel, T2 cancel, this get cancel. So only remaining term is Tn. Okay. So this is formula, you can write here also. So formula is Tn is equal to Sn minus Sn minus 1. Okay. So Sn is 2 into 3 raised to n minus 1. Sn minus 1 is 2 into 3 raised to n minus 1 minus 1. We can write 2 common. This is 3 raised to n minus 1. 2 is common. So minus 3 raised to n minus 1 minus 1. We write 2 common. So this is 3 raised to n minus 1 minus 3 raised to n minus 1 minus minus plus 1. 1 1 cancel. Now from this write common 3 raised to n minus 1 and this is 3 raised to n. So how we can write common? This is smaller, n minus 1 smaller than n. So this n write as n minus 1 plus 1, that we can write. That means with n write plus n minus 1, add and subtract 1. Now a raised to m plus n. A raised to m plus n, how we write? A raised to m into a raised to n. A raised to m into a raised to n minus 3 raised to n minus 1. So write this common. 3 raised to n minus 1. 3 raised to 1 is 3 minus 1. 3 minus 1 is 2. 2 into 2 is 4. So this is 4 into 3 raised to n minus 1. Don't write 4 into 3 12. This is 3 raised to n minus 1 into 4 is given. So this is our Tn. Now also question is show that it is a GP. So for GP we have to prove that ratio is constant. For ratio we want any term upon previous term. So now we know Tn. So from Tn either find out previous term or find out next term. So as this is Tn, find out Tn plus 1. So 4 into 3 raised to, now replace n by n plus 1. Replace n by n plus 1, minus 1 is already given, so 1 1 cancel. This is 4 into 3 raised to n. And therefore, now let us find ratio. R write as Tn plus 1 upon previous term. This ratio we want constant. So Tn plus 1 is 4 into 3 raised to n and Tn is 4 into 3 raised to n minus 1. 4 4 cancel. A raised to m upon a raised to n, how we write? A raised to m minus this n. So minus of n minus 1. So 3 raised to n minus n, minus of minus plus 1, these two get cancelled. 3 raised to 1, that is what? 3. Now this is what? Constant, which is a constant. What is meaning of constant exactly? Ratio we want constant means we want same. If we write here 1, we will get T2 upon T1. Answer we will get 3. If we write n2, this will become t3 upon t2, but answer is same. If we write 3, this will become t4 upon t3, but their answer is same 3, because here n is not given. So we can change here n. We will get t2 by t1, t3 by t4, t3 by t2, t4 by t3. But their answer we will get same. That means ratio we will get constant, that is same. Okay. And so this is a GP. So therefore, given sequence is a GP that we want to prove. Here question is, find sigma r from 1 to 10 of 3 into 2 raised to r. We know sigma means what? It is what? Summation. Like 2x plus 2y, we can write 2 common. So same here. 3 into 2 raised to r is given. So 3 is constant multiple of this 2 raised to r. So 3 we can write common. So 3 sigma r from 1 to 10, write 2 raised to r. Now what is this sigma that we know? So use your definition of sigma, 3 into. In this given term, first put r is equal to this first term, that is 1. So 2 raised to 1. Then write plus, because sigma means it is summation. So write plus. In this given term, put r is equal to, so 2 raised to r. R is next natural number. This is 1. Next natural number is what? 2. Then 2 raised to next natural number. After 2, this is 3. Then next natural number 4. Till what? Last term is put r is equal to this given term, that is 10. So this is 2 raised to 10. Okay. So we have to write 2 raised to first r1, then 2, then 3, then 4 up to this 10 and add them all. That is meaning of sigma. So suppose this is our s. So write here s. So we have to find this now. Write this here as equation 1. How we can find this sum of terms? These are, say, I think 10 terms. So how we can find this sum of first 10 terms? Check whether this is AP or GP or some HP. So now 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 up to 2 raised to 10 are in GP. Check this, your ratio is constant. Clearly this is constant. 2 multiply 2, you will get this. Multiply by 2, you will get this. Or divide this upon this, you will get 2. So here, first term is 2 raised to 1, that is 2. And common ratio is divide second term by first term, you will get 2. So we want sum of first 10 terms. This is 1, 2, 3, 4 up to 10. So there are 10 terms. So now Sn is a into r raised to n minus 1 upon r minus 1. We want sum of first 10 terms. So put n is equal to 10. A is 2, r is 2, n is 10 minus 1 upon 2 minus 1. So 2 into 2 raised to 10. 2 raised to 10 is what? 1024 minus 1 upon 2 minus 1, 1. So 2 into 1024 minus 1, that is 1023 upon 1. And therefore S10 is multiply by 2, 2 3s are 6, 2 2s are 4, 0, 2 1s are 2. This is S10, this is this sum. We want this sigma, that is S. Therefore from 1, required sum S is 3 into this sum, that is S10, 2046. So multiply this and find out answer. 3 6 are 18, 4 3s are 12 and 1 13. Now solve this, find out answer. What is answer of this? 6138. Okay.